Well, welcome to a special edition of ElmLive. Well, the first of many special editions this month. So, like I mentioned on the stream on Sunday, there's this project called Codevember. And if you look at the hashtag here on Twitter, you can see a bunch of the code related art. I guess I'm not sure the right word here. But basically the challenge is every day this month for people to write little code programs and put them up on CodePen or GitHub or the like. So you can see several people have already contributed and posted stuff today. And I'm not sure if I'll be able to keep up for the whole month, but I'm going to give it a try and see how things go for the first week or so. So, I was looking through some this afternoon, and I noticed this one that I was kind of inspired by. So I want to do something similar to this. And I haven't done any prep work beyond that, but I've got about 45 minutes here to do some coding. So let's give it a try and see what we can get to. So let's start. I've got a new Git repo. Let's see, I've got Elm 0.17.1. So let's set up our Elm package. .json. Let's get our text editor up. And I want to do this using SVG, but again, like we've been doing, I think I'm going to use this render package, Quartz Render, because it has a nice typed API towards making a lot of shapes, so we don't have to deal with, like today I think we're going to be using polylines in SVG, and to do that with straight SVG, you have to create these strings of points with move commands. So to avoid all that, we can use this render package, which is pretty nice. There's a couple rough edges in it that we've run into before, mainly with the ordering of matrix transformations. But we shouldn't need any of that today. So let's see. I'm going to elm package install this package. And let's make our new file, main.elm. And do I have ElmLive installed? npm install ElmLive. Let's use that. And we're going to import graphics.render. And main is going to be, let's grab this example. And that's finished installing. We're going to run ElmLive with main.elm. And it didn't like that. I think there was one problem with this render package, is that it requires an older version of the core library. So I think when we installed it, it messed up the Elm stuff directory. I'm just going to delete it and try building all this again. And a lot of that dependency and build product management is supposed to be fixed in Elm 0.18, which should be coming out in the next month or so. Okay, and in this example, we imported graphics.render and everything in it, so we don't need to qualify everything with render dot. All right, so now let's go to localhost, and there's our example app. Okay, so let's get started here. What I'd like to do is get a black background up, and here's basically what my plan is. I want to do something similar, but his kind of has little pieces that grow from the center if you click into the actual code. What I want to do is set up a grid and have paths randomly draw from the grid, and then just generate, when we start the app, a bunch of random paths and have those stroked with dashed lines, and then we can animate the dash. And maybe have like the grid parameters be some kind of parameter that we can use to configure it. So let's start out with a group. I'm going to define canvas size equals width 500, height 500, just to make this a parameter. Canvas size dot width, canvas size dot height. Then we're going to take this and let's use a rectangle instead, and we'll use the same width and height as the whole canvas. And let's actually resize this. Let's make this 600 by 450. And a little bit wider, 700. How about even more? 750 by 500. Cool, let's work with that for now. And I just want this to be a solid fill of black. There we go. Or how about a little off black? Maybe a little more, 15. All right, there we go. So now let's try drawing some lines. So I think there's something called polyline in here. Yeah, and I was looking at this earlier. So let's draw a polyline. It takes a list of points, and what is a point? A point is just a tuple of floats. So let's start with 0, 0, and let's try 10, 10, and maybe 10, 20. And then we end up with a line, which we need to convert into a form. So let's search in here. Great. And we can make a dashed line. I'm just going to use dotted for now so we can kind of see where the line is going. And what is this? This is the width of the line and the color. Okay, so let's have a width of 3 and then RGB maybe 220. All right, so we've got a little line segment here. And actually, I want this to move straight on the grid. There we go. Okay, so we're able to draw one line. So let's see. Let's go about making a random line. So what I'd like to do is use random here. And we're going to have a random.generator of a list of points and how do we want this to work? I want each point to be based off of the previous point. So actually, maybe here's what we want to do. I want to define a move, and we'll generate a list of random moves, and then turn those moves into points. I guess I'd like to have some kind of control so that, for instance, the line doesn't turn back on itself. I think we can do that still. So let's define a move, which will either be straight, or turn left, or turn right. Then let's create a random list of moves. I'm going to look up the random package. So I always forget how to run this manually. Okay, so we're going to use random.step, which takes a generator and a seed. So our seed for now is going to be random.initialSeed0. And our generator is going to be a list, and we'll tell it how many points to generate, and then have it generate points. So we're going to have random point is going to be a random.generator of float. And that should be easy to write. This is just going to be random.pair of random.float and another random.float. And we need to import random, I'm pretty sure. Okay. And what did we mess up here? Pair is expecting the second argument to be a random generator. We have to give coordinates to these. Oh, and actually, sorry, I'm getting confused. We don't actually need this. What we want is a random move, and this is a generator of moves. And to do this, I think we just want to generate, let's see, is there maybe something that'll do this for us? Custom generators, map, generate step. I'm going to check and see if there's something in the random extras package. Here we go. Okay. So I'm not sure where this would be. I want to find one where we give it a list of things and... here we go. Choices. Chooses a generator from the list of generators with equal probability. Great. And actually here's one with frequency. Cool. So let's actually use the frequency one. So first we need to install this package. Let me kill ElmLive for a moment. Elm package install. Let's see if that builds. Let's see, what's wrong here? Elm is not defined. Okay. I think the Elm stuff folder might have gotten messed up again. Not sure why that is having so many problems. Okay, there we go. So it's failing to compile. Okay, great. So now we want to import random.extra. Then we want random_extra.frequency. And that takes a list of tuples, and in the tuple we have the weight and the option. So what I want to do is give it a 50% chance of going straight, and then a 25% chance to turn left, and a 25% chance to turn right. Oh, and we've got to give it a generator in each case. Okay, so then we need a constant, and we should have that in here. Or how do we turn an A into a generator of A? We don't have that? Okay, well that must be in random extras. Oh, here it is, random extra constant. Great. Okay. So where are we at now? So we're going to take random step, right, and then we need our random generator. Our random generator is going to be a list of, let's generate 15 moves. So this will make a list of 15 items, and each item is randomly chosen from this generator. Then we have our seed. And what else do we need? And then that gives us back the value that we want and a new seed, which we are just going to throw away for the moment. So we'll just take the first item from the tuple. So that'll be a list of moves. Then we want to take our list of moves and turn it into a list of points. So let's make a function to do that. This is going to take a list of moves and give back a list of point. And to do that, we're going to need to do a fold, because each step, we're going to basically loop through the moves, and each step we're going to need to depend on what happened in the previous step. So we're also going to have some internal state as we do this. I guess actually we can maybe do this with well, okay. I was thinking if we should do this with recursion instead of a fold, but I think a fold will be good. So we'll have our init, which is going to be the initial value that'll be chained along through the fold. And we want to fold L, starting with the item, the leftmost item in the list. And we're going to have a step which will take our state of the fold, or no, so the state and the next move. And when we have that, okay, so the state is going to have the current position, which will start at 0, 0, the direction we're moving in, which I'm not sure the best way to represent this. I guess with just a new type. And then it's also going to have the list of points that we're ultimately going to get back, which starts at empty. Okay, so then our state is this tuple. The current location, the direction, and the result. And okay. Let's see. So we want to figure out our next direction. And that's going to be a case based on our current direction and the next move we're going to make. So I guess this is maybe not the best way to factor this, but let's just list all these out. So if we're going north and we want to go, actually, if we're going any direction and we're going straight, then the next direction is going to be the same direction we were going. If we're going north and turn left, that's going to be west. North, turn right is going to be east. West, turn left is going to be south. West, turn right is going to be north. East, turn left will go north. East, turn right is going to go south. And south, turn left is going to be east. And south, turn right is going to be west. Okay, so that's the next direction we're going to go. Then, I guess our new location is going to be case of new direction of, and if we're going north, then this is going to be, and I guess we should split this out into x and y. If we're going north, then this is going to be x, comma y minus 1. If we're going south, then this is x, y plus 1. If we're going east, this is x plus 1, y. And if we're going west, this is x minus 1, y. So that's our new position. And we also want to add the new position to the list of, to our result is what it's called. And it doesn't like, next direction. Okay, I like new direction better. Hey, The most unpronounceable name in chat. Yeah, welcome. Codevember is just a challenge to make a quick little graphics visualization every day in November. So I'm kind of slow at it. I don't do a lot of graphic stuff, but I'm giving it a try today. So I've only got like another 20 minutes, so I'm not sure what we'll be able to finish up, but I think we're getting pretty close to having something reasonable up here. Okay, so we just wrote this step function to do our fold, and we have this internal accumulator, which has our current position, our current direction, and the list of points that we're building up. And then we one by one get moves and fold it into this state. So now we can write our fold with the step function that we just defined and our initial state that we defined up here. And then we're going to fold over all the moves. And we should get back a list of points. So this function looks good now. Oh, nope, doesn't quite look good. Fold L is expecting the second argument to be a move. It is? It should be the second argument. Oh, okay, I think I have these arguments backwards. The new item is the first argument to the step function, and then the accumulated state is the second argument. Okay. And now we get back this state. So after we do the fold, we need to pull out the result that we want from the state. So we don't care about these, and that's the result, and we'll just pull the result out. Cool. So that looks good. So we create the path, and now we have a list of points, which means we can send it to the polyline function, and then we should be good to go. Okay. Let's see if this works. Cool. So there's a tiny little thing in here. So I was only moving by 1 pixel. So rather than 1 in all these places, let's make this distance. And let's just define distance in here for now as 12. Why not? There we go. Cool, so we have one random line. Let's actually make this go longer. So rather than 15 steps, let's do 25 steps. Cool. So now, let's generate several lines. So let's take, why don't we do this? Let's make a range from 0 to 20. And for each number, let's turn that into a random seed. Then let's take each random seed and generate a random list of points. Then let's take those, and then also throw away the new seed that we generate from that. Then let's take each list of points and create a path, and then convert it into a polyline, and then render it with dots, and then let's put those all in a group. Let's see if I did that right. Cool. There we go. And let's increase the distance here. Maybe 24. Yeah, okay. Cool. And then, rather than dotted, let's make these dashed lines. Does that even work? That doesn't seem to be doing anything. So what I want to do next is get these to be dashed. And I think there's some stuff down here for the line style. Yeah, here we go. So we can do a custom line style and give all these parameters. So instead of dashed, we are going to, let's see, I'm just going to call this draw line and define that here in a let statement. Draw line equals that for the moment. And now, instead of this, let's use line. Oh, interesting. And these, I feel like these are backwards, these arguments, like the line style should come first so that we can curry this function. But that's okay. We can, since we're making a little function here, we can swap these. So we'll put L there, and then I want to copy this, stick this here, and then color is going to be this line color. Width is going to be 3. Line cap, what are our choices? Line cap, let's use square. And line join, let's use sharp for that. Dashing. So this takes a list, and how does that work? They use 8.4 as an example. Let's see what that looks like. And the dash offset is 0 for now. And okay, so let's make these dash offsets bigger. That's still not changing anything. So let's inspect this a little bit. See if we can figure out what's wrong. So this doesn't seem to have anything related to dash strokes. Yes, it's an ElmMaze. Amazing. Interesting. Okay, so let's look up. There might be a bug in this render package. So let's see what's going on. CSS line dash. SVG line dash. Stroke dash array. Yeah, so I feel like this dash array is what should be happening here. Line join, stroke dash array. Let me see if I can add this parameter. Stroke dash array equals 8,4. Whoops. And then save that. How do I make you accept? Yeah, there we go. Okay, so stroke dash array is the right thing. It looks like there might be a bug in this library. I don't really want to debug that right now. So let's do this. Let's take our canvas and stick it in an html.div. Let's import HTML. Okay, so we'll actually stick this into a list. And then also, let's add a, oh, I don't need to do that with a pipe. I can just put html.div here, delete it from down there. And let's do an HTML, what I want is another tag, html.style tag. Can we make that directly? No. Okay, so we need to make an HTML node. I'm just going to stick some inline CSS into the document and add the dash through the CSS. And then this will be html.text, and we'll say polyline, and then our inline styles. This is kind of a hack. Oh, can you even set SVG CSS dash style? I hope we can set it in CSS. It can also be used as a property directly inside CSS style sheets. Okay. Stroke dash array is going to be 8.4, since that worked earlier. Looks like that's still not working. Oh, because we don't have our link. Does anyone remember offhand the right syntax? We need to put a type in here. Yeah, okay. HTML dot attributes dot type is text slash CSS, and then we need to import HTML dot attributes. And oh, it's not called polyline in here, is it? It's just called polygon. Okay, so maybe that was the problem. Polygon. And then this doesn't like the stroke dash array. Why not? Invalid property value. Oh, do you have to put pixels on here? No. What doesn't it like about that? Stroke dash array CSS. Oh, it's not a string. Ah, got it. It's just 8.4. Okay. I don't see anything happening on here. So stroke dash array, what do they use as an example? 2. And there's the stroke. Interesting. Cool. Well, or not cool. Okay, so there was something wrong with the way this page, or the way this render package is using dashes, or maybe there's something wrong with the way I'm using it. In either case, I am out of time for tonight, so I am going to leave this here and call it done. We have created a nice little random maze. Actually, what we should do is have it generate a different random one whenever we start. So let's do that real quick. We're going to need to convert this into a program. So we'll call this view, and we'll have this be called the seed base as a parameter. And main is going to be a program never. Main is going to be HTML app.program. And init is going to have an initial model of nothing. So let's define our type alias. Model is going to be a maybe int to represent our random seed base. Then we're going to have type alias message is just going to be an int. Then we'll have update, which is going to take a message and a model and always convert the message into the new model. And our command, when we fire this up, is going to do a random generate. Which, what does this do? Okay, so we just need to generate a random int. And we need to give that a range, so I don't think it matters. Let's just give it some arbitrary range. Subscriptions is going to be none. And we need to import html.app. Then we need our update function. And then we need our view function. And what did I mess up? Oh, update actually takes a message and a model. And we're going to do this, call it with message model, and then return no commands. What else did I mess up? So generate, we need to convert the int into a message, and for that we just need identity. And there, that works. Then we want to use this seed base. So we'll do a case seed base of, and if it's nothing, we're just going to draw a blank screen. And if we get a seed, then we're going to use it here. There we go. Cool. What is random.generate seeded with? Is asking in the chat. It somehow uses the current time, but from what I understand, it does it in a way that gives even distribution across all seeds. But that's implemented in JavaScript rather than Elm. It's part of some native code in the core library. All right. So I'm seeing some weird little artifacts here. Like there's these diagonal lines that are, oh, those must be like the fills of the polygon. So that looks like another interesting bug in this render library we've been using. It seems to be rendering these lines actually as polygons, and it looks like it set the fill on these polygons. Well, in any case, that is our Codevember sketch for day 1. So I will be doing another quick one tomorrow, so follow me on Twitter at AVH4 if you want to get notified, or follow me on Twitch if you want email notifications. And I will be posting this code up in a GitHub repo. So thanks for watching, and hope you have some fun writing code this month as well, and I will see y'all next time.